Another example problem, 0.02 moles of gas undergoes the process shown in the figure. So this is a PV diagram, as we've mentioned. Pressure is on the vertical axis, volume is on the horizontal axis. What type of process is this? What is the final temperature in degrees Celsius? What is the final volume, V2? All right. So 0.1 here, it has a volume of 400 centimeters cubed. So the units are labeled. It has a pressure of 1 atm. This final 0.2, it has a pressure of 3 atm, because we can read that off the graph. Now, as far as what type of process this is, we've talked about isobaric, so constant pressure, isochoric, constant volume, and isothermal in terms of PV diagrams. Isobaric would be horizontal line because the pressure would be held constant. Isochoric would be a vertical line because the volume would be held constant. This one's the hyperbola. So this is an isothermal process. The temperature is held constant. As the volume is decreasing, the pressure is increasing. All right, in an isothermal process, the relationship we have is that pressure times volume at any moment in time is going to equal pressure times volume at a second moment in time. But also, isothermal means constant temperature. So part B is asking for the final temperature, but that would also be the initial temperature because this is isothermal. The temperature is not changing. So for part B, since I know V1 and P1 and the number of moles, I'm just going to use the ideal gas law for 0.1 because the temperature is the same the whole time. T1 and T2 will be the same. So our temperature will be P1 V1 over NR. Now, in terms of units, since we are using R in terms of SI units, we will want our pressure in pascals. So the conversion, 1 atm, 101,300 pascals. We will want our volume in cubic meters. We know there's 100 centimeters in a meter. We need to cube that conversion. So this volume, 0, oh, it's getting stuck again, 0.0004 meters cubed. And they gave us, R is our constant, so we can find our temperature. So 243.8. This is in Kelvin because R has units of joules per mole Kelvin. The Pascal times the meter cubed is giving us the joule. The moles will cancel, so we'll be left with kelvins. It is asking for the temperature in degrees Celsius, so I do need to subtract the 273. And then I need to think about my sig figs. So the numbers, let's see, our moles is going to determine our sig figs. That's two significant figures, just the 0. So this temperature, both finally and initially, is negative 29 degrees Celsius. So this is our answer to part B. For part C, we want to find the final volume. So we want to find V2 up at this last point. We know V1 and P1, we know P2. Since the process is isothermal, we can use this relationship that pressure times volume at point 1 needs to equal pressure times volume at point 2. So V2 will be P1 V1 over, nope, not V2, P2. Okay, so P1, 1 ATM, V1, 400 cubic centimeters, or 0.0004 meters cubed. P2, 3 ATM. So, oops, 133.333 and so forth. We're getting 133 centimeters cubed. But again, if we go back to the fact that we only have 2 sig figs, we would want to say approximately 130 cubic centimeters. And so that is our final volume.